So as I said, my name is Danilo. Danilo P is my Twitter handle. It's also my account on GitHub, and it's also my email at amazon.com. So if you want to reach to me for any question after today, please feel free. So the first, unfortunately for you, I will annoy you with two presentations, not just one as it was planned. So this one is another presentation that I like it a lot because I think it gives an idea of where we are going with the IoT, with the Internet of Things. It's one of those words that was almost a buzzword for years. Now we are, I think, going into something more concrete. And we will do a live demo. I brought a toy that we can use to play a little bit and see how things can work. So why we are here talking about the Internet of Things? Probably because they asked me to do this presentation, but there's also a lot of interest around this topic. And the reason why there is such an interest, I think it's due to different aspects. One is that the Internet of Things can allow products to become smarter with time. And this is something quite different from what we were used to in the past. For example, Sonos, they build smart devices to listen to music. They are wireless. You can put them in multiple rooms. They would synchronize. And one thing that is quite peculiar of this physical device is that the previous model, they use it, the same physical hardware, the same model for 10 years, from 2006 to 2015. Now there is a new model, but for 9-10 years, they didn't change the hardware. They only upgraded the software. And if we compare this to other devices that we are using a lot, like smartphones, this is quite a long period because it was before the first iPhone ever was produced. And I think this bump will be nice in the recording. So what they did, they used an upgradable firmware to add the features to this device. And every year they were adding more features. And one feature that was really interesting is listening to music in a streaming, like with tools like Spotify. It's interesting because when they designed the product, listening to music in streaming was almost a non-existent option. So it was something that they were really not thinking. But at the end of the life cycle of the same physical product, they discovered that most of the users, they were listening to music in streamings, and only a very little. So the private library, the old MP3 files that we were used to use a few years ago, it's really the smart color you see in the top of this column. So the use of the device changed completely in 10 years, but they were able to make it smarter year over year. And they were also able to do this because they were collecting information on how the people was using their devices. So they were collecting information so that they can understand if they release a new feature, how it's used, or if it's not used. And this was the way they were able to do this very long life cycle for an hardware product. The second point for the Internet of Things is that the process that you put in place for your own products can be more efficient and predictable. And this is, again, the same approach that we saw with Sonos. So you have more data. You can collect information from a smart product, how it's used, which features are used, which features are not used. And you have more knowledge on your product, on the people using your device. It can also build a closer relationship with your own customers because you know what they do. And if you have a closer relationship, so if you release a feature, you immediately know if the people is using it or not. This is something that to developers sounds like agile, because in agile, one of the key important aspects is to have a closed loop, feedback loop, so that you can release a small feature and get immediately a feedback. So you can bring agile methodology to the hardware manufacturing process. That is something quite peculiar again. And then the Internet of Things can also create offerings that were not possible before. And one example that I like is Philips here. The Philips has a healthcare division. This is one project from Philips. It's called the Health Suite. And the idea was to put the clinical informations, the caregivers, and the patients in connections together so that patients can live at home but still have all the information that they need, and the connection with the caregiver is always on. So they could do that using sensors in the house and the sensors will check if the person is taking the medicine every day. This is the #1 issue with people that is not in a hospital, to be sure that they take the medicine every day. So they have a physical device that will literally print a bag with the medicine and will check that someone is collecting the medicine every day. They can put sensors on the fridge to understand if the person is having breakfast every day, at what time is having breakfast. Sensors on the bathroom door to know if someone is going to the bathroom, at what time in the middle of the night, how many times per day. And then you can check all these patterns to understand if something is changing. So if someone never going to the bathroom is starting to go to the bathroom 3 times per night, or someone having breakfast every day at 7 a.m. sharp, starting to have breakfast at 10, these can be signals that the caregiver can analyze and eventually get in touch with the patients. So I think this is one win-win situation for IoT, because patients are better at home than in a hospital, and probably it's also cheaper for the community to have the patients at home, but still monitored. And this is implemented using a home gateway that is connected to our AWS IoT platform that we will see in the live demo towards the end of this presentation. And the AWS IoT platform is acting as a bridge to make the Internet of Things world communicate with our traditional services such as Amazon S3, AWS Lambda, and so on. In doing that, Philips also moved 15 petabytes of clinical data of the patients on AWS, and you can think how high is the security level for this kind of information. So they were confident they were able to do that on AWS. I think it was quite an interesting project. Another thing that is changing with the Internet of Things is the product interface. In the past, we were used to use mediated interface, and probably for us in the room, it's OK to use a keyboard. But as soon as you start to go to younger people or elderly people, this is not the case. We saw a few years ago the rise of simulated interfaces, such as touch screens. And actually, this kind of interface is used very easily by very young people or elderly people. And I think the effectiveness of an interface can really be measured considering the range of age and scope that it can be used by. With the Internet of Things, we are probably going to go through another change where we will have direct interface, because with the Internet of Things, the product itself is the interface. You use a physical product, and the product itself is making it available as an interface. And we see that communication is changing again. We think that in the future, natural ways of interacting with things will be more and more common. For example, we have this device that we just recently started to sell in Europe, in the UK, and in Germany. It's called the Amazon Echo. And this device is a cylinder that you put in your house, and you can talk to her, I would say, and ask things, and you can really interface with a lot of things very easily. I had this connected with my smart lights at home, the Philips smart lights, and I could just turn on and off the lights sitting on the sofa. It's not that I don't want to rise myself and go to the switch, but it's very convenient. And after some time, it seems strange that to open a window, you have to go and do that by yourself, because it's so easy to ask for something to happen. And we also see that young people, again, and elderly people, they start to say thank you, goodbye, to interact with the device in a different way. I think it's OK. We should not tell to our children to be unpolite to physical devices, but it's a strange thing. And this device is open so that everybody can contribute and extend its capabilities. So we have the Alexa Skills Kit that enables you to add a skill. It's how we call a procedure that you can enable with the device. So you can, for example, Uber added the possibility to ask a Uber cab just by talking to the device. And there is just a marketplace. You just need to create a web service. You can use AWS Lambda or any internet-reachable web service to build a skill, and then you can register it to the store. And the other part is the Alexa voice service. This is the voice recognition part. So the device itself is using this service when you talk to it. But if you want, you can use this to integrate the Alexa voice service in any application or physical device. So we have car manufacturers that are evaluating the use of the Alexa voice service in a car. And it makes sense because in a car you don't want to move your hands out of the steer, so you can just talk and ask to the car how many miles I have left if I don't refuel, or something like that. And there are also mobile apps that are integrating the Alexa voice service. There is no cost in using these two features if you want to integrate them in your own products. But still, the Internet of Things is starting to come. There's a lot of advantage, but a lot of efforts are still required. First, devices are hard to connect and manage. The first connection is one of the big problems if you want to reach a broad consumer landscape, because you don't want an old person or a very young person to play with Wi-Fi too much. Things do not operate out of the box, so there's a lot of effort on developers to make the hardware device communicate with a backend application. And there is also a low signal-to-noise ratio in the data. So usually when you have a large-scale deployment of sensors, you can collect a huge quantity of data, and then maybe you need to process only a small subset of it. But still, the cost for managing this huge quantity of data are high. So it would be interesting to have some way, and we will see how we are trying to solve this in the demo, to remove the noise and collect only the subset of data that you need from the devices. And then another thing that we say is that applications in development and hardware device development, they are still two different worlds, and they don't communicate so much. So we see on one side the old world of machine-to-machine telemetry devices with their own skills, their own developers. And on the other side, we see the web mobile applications with RESTful interfaces and different protocols. So these two worlds, they still don't communicate very well. And this can be another issue because you don't want to fragment the development community. So let's see how we can try to make IoT simple to use and to build and innovate as we did in other areas, especially for developers, builders, and makers. So one aspect that we really want to take care is security, because when your toaster is connected to the internet, you want to be sure that nobody is connecting to it from outside the world. And scalability, because if you build a project, a prototype for 10 devices, if you want to scale and go to thousands of millions or even billions of devices, you don't want to change everything every time that you scale. You want to use the same infrastructure, the same tools to scale from a few devices to millions or billions of devices. So that's why we released this platform. Now it's almost 2 years. No, it's 1 year that we release it. And it's trying to cover all these aspects. So I will show you how it works, and then we will see the live demo. So the first part is the device gateway that is managing the authentication and the authorization of the devices, of the things that are connected. And we do that using and supporting multiple protocols. So for example, we support the classical AWS authentication for web services, so over HTTPS. But HTTPS is not very lightweight. So for a smaller device that maybe run on batteries, we support MQTT. That is a message queuing protocol, very low level, very light. But MQTT, to be secured, needs some additional layer. So we support MQTT using mutual authentication with TLS. So there is a certificate on the device, a certificate on our site, and there is a mutual authentication to connect and talk with the device. And we added over the, now it's quite a lot of time ago, more than 6 months ago, supports for WebSockets. So it's actually secure WebSockets. And inside these WebSockets, we use the MQTT protocol. And this enables to use different things, different devices, but also to connect web browser to the platform very easily. In fact, you can use AWS IoT without physical things, just using WebSockets, and it can still make sense. I will talk about this in the second presentation. Second part here is the registry. So for every device that you connect, we have a metadata repository where you can store the firmware version, the serial number. It's a key value store that is very useful because usually when you have a large scale deployment, you want to trace what's deployed. So in terms of firmware upgrades, also in terms of hardware revision, because if you start a large-scale deployment that will last for more than 1 year, probably you will have hardware upgrades from on the device side, and you need to know if a device has changed, because maybe you have to push a different firmware to that device. So the device gateway is managing the integration and will provide the publish and subscribe broker for the MQTT protocol. The real engine is the part that is trying to reduce the noise of data. So if you collect a lot of information from the devices, they come through this MQTT protocol where you have topics. I'm not entering into details for now, but the idea is that you can filter the data here using a SQL-like syntax. So for example, this is a kind of topic that you can have with MQTT. They are hierarchical, so you have all your things, then maybe thing 2 is one of the device, and then maybe this device can change color, so you have a color. And if you have all this information flowing here, you can select from this topic and then filter the data only the device where the color is red, so that maybe it's signaling an issue. Maybe the temperature is too high. And you can filter this data, and then the real engine can bridge this filtered data with other AWS services, like store only the data where the color is red, or launch a Lambda function to process the data when the color is red. Another interesting concept is the device shadow. I was talking about this problem of application development using standard RESTful protocols and the Internet of Things that is still using protocols such as MQTT. Another problem is the connectivity of the devices. If you have a distributed deployment, it's very common that you lose network connectivity for some time. And if you have a state in the device, you have to manage this in the complexity of your own application. So the developer must check, is the device connected? Yes, then I can check the state. Is not connected? What was the last state reported? It's all a lot of complexity that you need to manage. That's why we introduced the concept of device shadows. It's a virtual device that is running on AWS, basically, and it will keep the last reported state so that you can always get the last reported state, and you can also change the state. If the device is connected, the device shadow is just a pass-through, so it's like talking directly with the device. If the device is not connected, your application can still check the last state, change the state, do whatever they want. When the device is back, it will get the delta, so the difference between the reported state and the desired state, and can synchronize. So the application development is much, much easier. And the device shadows has RESTful APIs, so you can use RESTful APIs to interact with it, and you don't need to know low-level protocols in your application development. So I'm talking about not the internet, the device side, but the application side of the development. And finally, but not for importance, there is a few device SDKs that we released as open source. They are on GitHub that you can use to write the application running on the device. So we now support embedded C, JavaScript, Java, Python. I will use Python in my example. Python runs very well on Raspberry Pi, that's the reason. Arduino Yun, and then mobile SDK for Android and iOS. So this is the demo that I want to build. It's a little bit going towards the second part of the day, so bear with me. So the idea is to create a demo where we have a lot of IoT sensors. Here I have a single device, so I will emulate a few of them. These sensors, they will send information using this MQTT protocol. It's a publish and subscribe protocol, and they will send information. And here they enter in the AWS IoT platform. It's the blue part of this diagram. Here, the AWS IoT rules will get this information, filter, change it. We will see how, using this SQL-like syntax, and we'll send it to the Kinesis platform. Amazon Kinesis is a platform for managing streaming data. So the first part will be Kinesis FileHost. It's our service that will automatically store all the data on S3. It's one option, but usually you want to store all the data because the cost of storage is very low now, and you can then eventually change and launch new algorithm in the future. So this is what we see a lot of companies are doing. So we store everything. And we also pass this information to Kinesis Analytics. Kinesis Analytics is a a relatively new platform that we launched. It's publicly available since August. And the idea here is you have a stream of data, and you can run SQL query on this stream of data, and the output goes on another stream. So you can really run dynamic analytics on your platform. And it's interesting because you can create concepts such as sliding windows on the stream of data. So you have a SQL syntax, but you can run a select only on the last 30 seconds or 5 minutes of data. So every time that you run this select, you have a stream of flowing data. You only address a subset of the data, and you can compute moving average or other things. This is usually very good for the Internet of Things. For example, if you have lots of temperature sensors, probably a few of them are not working, so you can do anomaly detection to check what are not working. Or you can average. So if I have 10 sensors in this building, I can take the average. Probably it's more correct than the single value of all of them. And the output will go to a kinesis stream that is processed by a Lambda function. This Lambda function is actually, so it's a piece of code that is actually taking all the information and publishing this information back to the platform. And here I have a browser application that is subscribing to this topic using WebSockets, and it's receiving all the information so that you can process the information on a web browser. The interesting part is this is completely serverless, so the JavaScript running in the browser is connecting to the AWS IoT platform, doing all the logic is running on the web browser, and there is no server-side components running. Everything is running in the browser. I have the connection, and I'm processing data. So since I wanted to show something that I still didn't completely build, I'm using in this demo GeoHashes. So is everybody here familiar with GeoHashes? So who is familiar? Not a lot of people, so that's why I added a few slides in the last, So the idea is if you have devices spread on the world, they can ship the information on latitude and longitude, and then you know the location of the device. And one of the things that you can build is like a heat map, like knowing the temperature in different areas, averaging all the devices that are in a single area. Usually you need two variables to describe the position of something in the world, latitude and longitude, and this makes sense with what we studied at high school. But actually with GeoHashes, you can use a single variable to specify the location of that device in a bidimensional space. So the idea is here, this is the world, and let's say we have a device here in India, and I want to specify where it is. So usually I have latitude and longitude, and it's OK. But another approach that is used by GeoHashes is this. Like, let's start to splitting this map in two. And is my point to the right or to the left? To the right. This is not a difficult question. So let's say if it's on the right, I use a binary 1. If it's on the left, I use a binary 0. So this is a 1. Now I can do the same on the other direction. It's on top or below? Top. On top. So top is 1, and below is 0. I don't remember the actual order, but it doesn't make sense. So we have 1 and 1. And then I can continue splitting in 2. So it's on the right or on the left. This time it's on the left. So it's 1, 1, 0. It's below or on top, it's below. So it's 1, 1, 0, 0. So every time I split the map in 2, I have a binary 0 or 1 that is telling me, and then I can continue for as much precision I need. And this is bisection. So for people that played with mathematics, they know that bisection, they converge very quickly. So you can be very precise with a few, not a lot of ones and zero. So you can specify the location of this pixel on the world using a list of 1 and 0, so a very long binary number. And a binary number, you can put it in a different format. So from two variables, we can use a single string. And for example, this latitude and longitude, you can write the binary number in different formats. I'm using base64. It's one of the formats that you can use to render it as a string. It's very common because it's much more compact. But also unsynced integer are used. So I'm converting this to this GeoHash. Do you know which location is this? It's very easy. It's worse. So this is the GeoHash for. We will see live. It's the very center of, I suppose, of Warsaw. So let's move on to the demo. So I have this toy here. that I brought. So, and this device has sensors, but it's just a single device. So I will use it to generate random temperature and random humidity from different locations in the world. So let's use this is the, oops. So here I'm connecting. It's exactly what you see on the screen, but it's probably much easier to follow. And I have an application. So IoT demo. And this part here is written in Python. And I have a list of towns with the latitude and longitude. And what I'm doing, I'm connecting to the platform. And then I'm publishing a random, let's go where this part here. So I'm basically generating a random temperature, a random humidity. I choose a random town, and then I send a signal to say, hey, this town has this temperature in this moment of time. And then I'm converting in this line here, geohash.encode, the latitude and longitude in a geohash. What happens is that it's published in this topic that it's here. So the topic is called, I don't know if you can see it, maybe I can zoom a little bit. So I use, the topic here is a hierarchy. So my app, the name of my app, slash the device name, that is the town, like Warsaw, Rome, Milan, New York. Then slash sensor, and then the sensor name, like humidity, temperature. And so the topic will say the town, the place, and the kind of sensor. And inside this, I'm sending data that will contain latitude, longitude, the geohash, and the value of the sensor, like the temperature. So all this information will go to the AWS IoT platform. And the AWS IoT platform has this long string that you see here is my device here, where I generated the certificate to connect the device. So it's the first time you connect a device. I use the web interface, but of course, if you have a large-scale deployment, you can automate everything, and or you can even use your own certificates if you want. And then I created this rule here, and the rule is quite interesting. So as I said, rules have a SQL-like syntax. So what I'm doing here, if I'm not falling down, is I do a select from my app. You remember all my topics start with my app. Then I have a plus. A plus is like an asterisk for MQTT, but it's replacing only a single path in the topic. So my app, here is the device name, like the name of the town. So for every town, slash sensor, slash plus, and here you know the second part here would be the humidity temperature. So I'm basically say select for every town and for every kind of sensor all the information. And in the select statement, I'm saying the first output that I want is topic 2. So this is an internal function that will take the second part of the topic. So this plus here, so the name of the town, as the device. Topic 4, the fourth part, 1, 2, 3, 4 is humidity or temperature, the kind of sensor. And then I have as sensor name, and then I have an asterisk. That means everything else is in the message added at the end. So I'm extracting information from the topic, and then taking all the information and sending it to some AWS service. Is it clear? I don't expect it to be 100% clear, but I think at least the idea of it. So this is how you can extract. I could also filter here. And maybe I could say, I'm only interested in the town that report me a temperature higher than 40 degrees or lower than 0 degrees, because those are the temperature that maybe where I need to close the window or increase the temperature of the heating system. So I could add a where close here and filter the data. Here I'm taking all the information for simplicity. And then you can add an action. In this case, I have this action using Kinesis Firehost, the streaming platform, to publish all this information to Kinesis And I'm just saying that since this will automatically group more records in a single message, to use the new line as a separator so that I still have all the records splitted. This platform will automatically use the JSON syntax, so all the message will be in JSON. And if I want, I could add a new action in the same rule. For example, I can say, take this information and send it to a CloudWatch Alarms, to a metric, write it to DynamoDB, our NoSQL database, write it to Elasticsearch. It's a very common platform, and you don't need to run with GeoHashes because Elasticsearch has geospatial capabilities by itself. I can republish directly from here to the AWS IoT, so I can take a message that maybe is coming from a temperature sensor, manipulate it, and send it back to a device. So if I have another device that is an electronic window, I can say if the temperature is lower than 10 degrees, republish the message to the window that will automatically close itself or increase the heating. In this case, all the logic will be here. I don't need to run any logic on other AWS services. Or I can use, and this is very interesting, Lambda directly. Lambda is a possibility to run a function to process this information with a serverless approach. So I can straight take each record here and process the record with a Lambda function. So in this case, I'm sending everything to Kinesis. If we go on Kinesis here, we go in so the flow is going through Kinesis firewalls, and then I have Kinesis Analytics to process this data. And if I go here, I can open the application detail. So I have the source. So if I go on the source, now there is no data flowing, so it will not give me anything. Let's go on the SQL part. So this part here is the SQL statement that I'm running on the flowing data. And it's an interesting concept to run SQL on a flowing data, not on a static table. And basically, I create a destination stream. Then there's this concept of creating a pump that will inject data in the destination stream. And what I do here is, this is the core, the select. I will zoom it a little bit. So maybe not everybody is familiar with SQL, but it's quite easy to read. So the main concept here is that I'm not selecting from a table, but I'm selecting from a window that is a 5-minute sliding window. This is the name of the window, and I select as partition in the data by device and sensor for the last 5 minutes. So this is creating a virtual window that contains only the last 5 minutes. And then I select the information here, and I can run, for example, since it's partitioned by device and sensor name, I can group by this information, and I can calculate the average sensor value. So for the temperature, I will get the average of the last 5 minutes reported for every device in this case, because I'm keeping the device outside of the group by. And then I also take the minimum arrival time, and the maximum arrival time, so that I will know for every device the average of the last 5 minutes, the minimum time in this average, and the maximum time that I considered in this average. That this should be roughly 5 minutes. And then I publish this information on another stream. And in this other stream, I have a Lambda function that is processing this data. So this is probably not the most important thing, but basically, so this part here is written in JavaScript. And I receive all the data, and I publish the information back to the AWS IoT platform. So, and I'm creating a new topic that is my app, the device. And instead of sensors, I have average to distinguish my message from the other message. So all of this is going to flow very soon. So let's go here. I have this. No, I think I have it here. So no, desktop, IoT. Okay, it's this one. So now I will reload. So this is a static page that is already connected to the platform. Now I can go here and start this generator. So I will start to send the data. And now the data is going to is going through the platform. So you see the speed of it, and it's going back to the device. So here I have like the device, Beijing, Buenos Aires, and Warsaw. It's at the end because it's sorted alphabetically. And then I have the geohash that I computed, the kind of sensor, humidity, temperature. This is the latest reported value. So this is the message coming straight from the device. And this final part here, these 3 columns, is the average over the last 5 minutes, the minimum time, and the maximum time considered in this average. This is UTC time. So it's a couple of hours different. And so this part of data is coming from the device. This part of data is coming from the flow of the device through the analytics platform. And then the Lambda function is publishing the information back. And this is just JavaScript running in this browser that is receiving all this information. So if I had better UI skill, I could very easily take this geohash, convert it back to a latitude and longitude, and put it graphically in a map. So it's not so difficult. Another interesting part of the geohash is that you remember every time you reduce the size of the block in the geohash, you are adding one bit. So if I remove one character here, I would have the same location but with less precision. So if I group by, and you remember in the select statement I could group by, on a subset here, I can say 8 characters is enough for my precision. I group by the first 8 characters, and I could very easily create a heat map. So I group the data not for every sensor, but I only want to know all the sensors coming from this area, and I can do the average of that area. So with one SQL statement in the Kinesis Analytics, you can build a heat map knowing the average temperature of this area from all the sensors coming from that specific location. So this is how I am introducing geohashes. As you see, it's not finished yet, but it's quite easy. And what I want to show, I will stop for a moment the injection of data to see more visually how geohashes work. So I stopped. Now you see that the update stopped on the browser. I copy here the geohash for Warsaw, and I have this. This is a web application that has been created. I can paste here these geohashes. So this is the whole string, and this is the geohash. So as you see, there is no block here. So it means that it's very small, the partition. And if we zoom out, I think you can quite easily recognize that it's Warsaw. So if I remove one character here, still I don't see the block. It means that it's smaller than what we see. If I remove, now we are starting to see a very small block here. So this is to give you an idea of how fast and how high the resolution of geohashes is. So if I remove this, now this area is here. This is the area. Now we're starting to see a few blocks. So with 7 characters, we have roughly the size of a block. With 6 characters, we have this whole area in the center of Warsaw. With 5 characters, we have this area here. Of course, it's not an exact rectangle because latitude, longitude, they are quite a strange, messy mapping of a sphere into a plane. And if I remove another one, we see we have this area here. And then we have this area of Poland here. With 2 characters, we already have this, so almost all Poland and a slice of Germany. And with 1 character, we have all this area here of the world. So if you group by the subset that you want, you can extract a heat map and group data with Kinesis Analytics and build everything without one line of code, a complete serverless application manipulating data from sensors and publishing it in a map. So this was my first. So I'm going back just as a review because we saw everything. So we saw these are the device there sending data. Then the data was manipulated by the SQL rule sent to Kinesis Phyros, mainly because I need it on Kinesis so that Kinesis Analytics could run the SQL sliding window here. And then I publish it back, and the Lambda function was sending the average back here. And this application here is JavaScript running in the browser, was connecting and subscribing to my app in that case, I use the different symbol to say all the subset topics. So everything that was coming from the device and from the Lambda function was going here, building that horrible table that I was updating almost in real time. Does it make sense?
Yeah.
OK, so if you have any question, I'm happy to take them. I think we have a few minutes, right?
Yeah. 7 minutes.
7 minutes. Otherwise, we have more time for the break. Any question?
Another question. Do we already have to have a Lambda function? Can we use the Kinesis stream just to inject the data into MQTT directly without the Lambda?
So currently, there is no way to inject directly. So the Kinesis has these 3 platforms now, these 3 components. The stream is the low-level component, and it needs an application. It can be a Lambda function or any application using the Kinesis API, getting the data and manipulating it. Analytics is only reading and writing to streams. Kinesis files can write on S3, on Redshift, and can write on Elasticsearch. So there is no republish back to the IoT platform, as far as I remember. But it surely can be an option. So this can be an interesting thing to add to Kinesis files. So of course, you still need some logic. In this case, I'm really republishing everything without any manipulation. So you could probably do that here if we had a feature. Normally, you probably want to do something. So here I'm using MQTT to publish back. But if I want to use this information to change the state of a device, like opening a window, turning a light on, then I would probably use the device shadows API to change the state of the device. So that I say, OK, open the window. And then the message will go here. If the window is connected, it will receive the message and hopefully open itself. If the window is not connected, the state will stay in the AWS IoT platform. As soon as the window is online, it will synchronize. So it's better than MQTT because it's more permanent.
How do you authenticate the device? Because I believe these endpoints are open to everybody.
Yeah.
And we need a way to authenticate that the device is authorized to write to the stream or to the IoT.
This is absolutely a very good question. So if you use MQTT, so that's the most common scenario. As I said, it's a mutual TLS authentication with a certificate on the device itself. The certificate can be generated by us or imported by someone that is generating it. And if we go back here, this is the command that I run, since I'm a very lazy person, is actually this one. And if you see, when I started the device, I was passing. This is the startup. So I was passing the endpoint. So every user has a unique endpoint to connect. Then I was passing a root certificate, and then the local certificate, and the local private key that has been generated. So everything is installed inside the device. And I'm using this 3 information, the root certificate for the CA, and then the local certificate and the local private key, and there is a public key on AWS, to start up this demo and connect securely to the device, the platform.
Okay, so I understand in this IoT scenario, we can trust any certificate we will generate. I mean, we can install root certificate, not the public one, but
Yes.
owned by us, and this will be trusted.
Exactly.
Okay.
And the certificate lives here. So when you create a resource, so this is the graphical representation, you have APIs. You create a thing. You give it a name, like my sensor. You can create thing types if you want. You can add attributes. This is the key value store, the registry. The space is not allowed. And then when you create and when you connect the device, so this is the device, I connect it to a physical thing. You choose the SDK, for example. This is just for the example code. And here I now generate the certificate and the policy. And I can download the public key, the private key, and the certificate. if you want to import, there's a similar procedure where you import your own devices. So it's really in the connecting phase. Slightly different was for the browser. So the browser application here, this one is JavaScript running in the browser. So I'm not using, so I'm using MQTT, but since this is running on a browser and it's a JavaScript that I download, I don't want to put credentials here. So what I'm using, so everything is in this JavaScript file here. I'm using Cognito. So Amazon Cognito is a service that can create authenticated or non-authenticated credentials. In this case, it's non-authenticated because there was no login. And I give permissions to only read, so only listen to these topics. But you can easily add a web authentication using some L or anything else. And then if you are authenticated, AWS Cognito will check the authentication with the authentication provider, and then will give you the rights to read or write from specific topics. So in this way, you can have a web application. OK, so if I'm here all day, and I will do the last presentation, so any other question is welcome. Thank you.